Okay, so now we know how to take measurements and write measurements down. What we come across all the time is data in a book somewhere or in a journal somewhere that has some number of significant figures listed, right? They write it down the same way we write it down. And we want to know how precise is the answer. And in order to do that, we have to be able to count the number of significant figures. And so we need to know what numbers are significant and what numbers are not. And this comes down to zeros. All non-zero numbers are significant all the time. But zeros can screw us up a little bit. So we got to learn the policy on zeros, okay? So step one, all non-zero things are significant. Interior zeros. That means zeros between two numbers. Those count, okay? Those are significant. So if I have the number 1008, all of those zeros would be significant because they're between two other numbers, right? So these count. Trailing zeros after a decimal point. These count. So something like 3.100. Those zeros count. Okay? Trailing zeros before a decimal point. So something like 300.15. Or just 300 point. These zeros are significant. Leading zeros are not significant. So something like this. In this number that I've just written, there are only 3 significant figures. One of the easiest ways to deal with leading zeros is to put your number in scientific notation. When you do that, you eliminate all leading zeros, and we don't have to worry about them anymore. So if I were to rewrite this number as 4.15 times 10 to the minus 5, I can clearly and easily see that there are only 3 sig figs in this number, right? That's my method of choice for dealing with leading zeros. I take the thought process out of it by putting the number in scientific notation, okay? So these zeros, again, do not count as significant figures. This is where we're going to deviate from the book a little bit, okay? Your book says that trailing zeros at the end of a number before an implied decimal place is ambiguous. So what they're saying is this, 300. They're saying we don't know if those zeros are significant or not. What every other book in the world will tell you is that those zeros are not significant, okay? So if you have a number 300 like this, there's one significant figure and it's the 3. If you have a number 300 with a decimal point like this, then all 3 of those are significant, okay? That makes a difference. If you write the number 300, 1 sig fig. If you put the decimal point, those zeros now count, okay? Because now they are trailing zeros before a decimal point, right? The reason we care about this is, first of all, when we're doing math, we're going to need to know how many sig figs are there because there are rules based on sig figs. And second of all, the number of significant figures tells me how precise something is. So if I've got 2 data sources and one of them's got more sig figs than the other, then one of them is more precise than the other, right? Okay, we do have these things called exact numbers. Exact numbers have you can think about them as having an unlimited number of significant figures. And what we mean by that is that we're not going to consider them for precision's sake, okay? An exact number, right? So if I tell you there were 7 pennies there a minute ago, that was exactly 7 pennies. We had a picture of pennies up earlier, right? So that's only one significant figure, right? 7 is only one significant figure. But because that is an exact number, we're not going to let that hinder our calculations in any way, okay? And there are lots of things that can be exact. So things that we count like that can be exact. Numbers that are part of an equation. So if I had something like 3x, that 3 would be an exact quantity there, okay? That would not play a role in our precision, right? Some defined quantities are exact. So we said the other day that 1 inch was equal to 2.54 centimeters, right? In this particular thing, this is a definition. So this has an infinite number of sig figs. This is an exact definition, okay? Even though it looks like it only has 3 sig figs, defined quantities are infinitely precise, okay? Some conversion factors will be defined quantities, like that one, like the 1 inch to centimeters. Some conversion factors are not, like the ones I put on the board for you the other day with feet and steps and that kind of stuff, right? Those were not exact. Those were rough estimates. So those would carry some level of precision, some number of sig figs. Let's practice. Let's see if we can figure out how many sig figs are in each one of these numbers, right? So you tell me, 0.0035, how many sig figs are present? 2. What are they? The 3 and the 5. That's right. How about 1.080? Four. That's right. The 0 in the middle is an interior 0, and the 0 at the end is a trailing 0. They both count. 2371. That one's easy. 4 sig figs. Anything non-zero counts. All right. How about the scientific notation number? We only look at the decimal part of scientific notation, right? We don't look at the times 10 to the stuff when we're considering how many sig figs in scientific notation. So this is the only part that counts. And how many is there? 3. All right. What about something like 1 dozen equals 12? Say again. So 12 has 2, right? But this is a defined thing. We define a dozen as 12, right? So that's an exact thing. There's an infinite number of sig figs here, right? Unlimited. And this plays a role in when we're doing addition and multiplication, division with significant figures, okay? What this means when I say unlimited sig figs means don't count them when you're looking at the number of sig figs to find an answer, okay? All right, how about 100.00? How many? 5? 3? So let's see if we can define the types of zeros that we have. We know the 1 is going to be significant. Do you agree with that? All right, so what about these zeros here? Do they count? Why do they count? Because they're trailing zeros after a decimal, okay? So they count. What about these? Well, should we define them as trailing zeros before a decimal? Or should we define them as interior zeros? Yeah, either way, they're significant. Both of those things are significant, right? So these are all significant, and we get 5 sig figs. What about 100,000? This is the only one we can be sure of, right? Your book is going to say this is ambiguous. Every other book is going to say none of those zeros count because they're trailing and they don't have a decimal point, okay? So 1 sig fig here. And what about 100,000 with a decimal point? All 6 of those count at that point, okay?